Welcome back to the Flex Diet Podcast. I'm your host, Dr. Mike T. Nelson. On this podcast, we discuss all things to increase lean body mass or muscle, decrease body fat, increase your performance, all without destroying your health using a flexible approach. Today on the podcast, my good friend, Dr. Sara Campbell, and you may remember her from a previous episode where we talked about exercise and gut health. And today the podcast is brought to you by the Flex Diet certification. This will open up again in January of 2022. So the Flex Diet certification is 8 different interventions to maximize your knowledge in nutrition and recovery. This can be for yourself, or it was specifically designed if you are a coach. It's a complete system of how to know where to start with your clients regarding nutrition and recovery. So the 8 interventions cover everything from protein to dietary fat, carbohydrates, obviously your macros, sleep, NEAT, so non-exercise activity thermogenesis, aka walking around, movement, exercise, fasting, micronutrition, and much more. The nice part is I put it in a complete system for you, so you'll understand the context of the system, just based on metabolic flexibility and flexible dieting. You'll understand a technical primer on each one, so you'll know all the details that you need to know, and you'll have the explicit action items of what to do for each particular one. Each intervention comes with 5 specific action items and a system so that you can lay them out for your clients in a flexible approach. So it opens again January 2022. As of right now, we also have CEUs for it through the NSCA, possibly CrossFit next year. We're still waiting to hear back from them on that, NASM, and ACE. So if you're looking for CEUs to get ahead of the game, this would be a great place to get them also. So go to flexdiet.com, FLEXDIET.com. As I mentioned, Dr. Sara Campbell is back on the podcast again. She did an earlier episode that we'll link to about exercise and gut health. I got to see her recently as I was out presenting for the ACSM meeting there about 4 weeks ago in Pennsylvania, which was an awesome time. And we talked about some brand new research that she is working on with her lab. Super interesting. Especially the parts where we talk about the relationship potentially between antibiotics and your gains. This could be type 1 muscle hypertrophy and even changes in aerobic cardiovascular output. These were done in some early mice studies, but some really, really interesting information. She is in the process of submitting these for publication. So you'll be able to hear all the latest information before it is even in the old PubMed. So brand new stuff that you so far haven't really seen talked about anywhere else, but really good stuff. So Dr. Campbell is the director of the graduate program in kinesiology and applied physiology. She is an associate professor there at Rutgers University in the Department of Kinesiology and Health. She is a PhD and also a faculty at the ACSM, American College of Sports Medicine. Her lab is affectionately known as the Red Dragons, or also the Poo Crew, since they are looking at fecal samples in order to determine impacts on the gut microbiome for many different interventions. And at the end, we also talk about some very cool stuff on cold exposure and brown adipose tissue and how that may work also. So enjoy this great interview with Dr. Sara Campbell. We did have a little bit of audio that comes in and out, probably around halfway or a little bit after. We tried to clean it up as best we could, so I apologize for that. The internet wasn't in our favor, but I don't think it interrupts things too much. So enjoy this interview with Dr. Sara Campbell. Well, thank you so much
Yes.
for being back on here. I appreciate it. You were on here talking about gut health and exercise in season 2, episode 9. So it's awesome to have you back, and you've got some new super cool data for us again.
Yes. Well, first, thanks for having me. It's always a pleasure to visit with you, but also thank you for coming to Harrisburg to, give that awesome talk to the Mid-Atlantic ACSM chapter meeting. So
yeah, thank you for inviting me. That was super fun.
It got fantastic feedback. So
good.
Yeah. You gave a wonderful talk. It was super well attended, and it was just wonderful to have you, and then to, get to go out and enjoy some beverages and fun things like that too.
Yes. Is it the Trolls Brewery or Trogue?
Trogs, right?
Trogs. Okay.
Yeah.
Yeah. Next to Hershey, so there was, yeah, they had really good dark beer, really good food, and just a super cool place. If people are around that area, I'd recommend they check it out.
Yes, definitely. And, it was good company. I worked with some really great people in the chapter who, we had a nice conversation with. So that was fun too.
Yes. And one of them's visiting White Bear Lake. So we'll get together when he's in town.
Yes. Dr. Sismarski. Yeah.
Yeah.
Too funny. Nice. So anyway, so let's chat about this crazy data we have going on here.
Yeah. Wherever you want to start and jump off. I know, you can decide whatever you want to make public or not. I'll leave it there.
Well, what's interesting is we're finalizing some of those, publications, and, a lot of it's had to been sent off to, NIH as part of, grant proposals. So it'll eventually be out there anyway. And then, my colleagues at Kentucky in John McCarthy's lab, and Taylor Valentino is the lead author on that paper that just came out. So that on skeletal muscle and how providing antibiotics kind of really diminishes capacity of hypertrophy, and in particular of those, type 1 muscle fibers, and they use some female mice. So
yeah, so talk a little bit about that to start, because I think that would be like very newsworthy, or something that is novel but yet common, that happens in humans. Granted, it's done in mice, but still very interesting.
Right. And so, it kind of piggybacks on some of the conversations we had in Harrisburg. So we kind of, tell the group about that a little bit. But, there's a John McCarthy's down in Kentucky. He's been, looking at skeletal muscle for a while, and he has this really unique POWER, POWER protocol that he uses to induce hypertrophy and look at some of these, really cool aspects of how muscle adapts to exercise regimes. And I had the privilege of his doctoral student, Taylor Valentino, inviting me to come down there and talk a little bit, because they were getting interested in the microbiome. And so what they did is they took a cohort of female mice and kind of introduced them to this, POWER protocol that they use for hypertrophy. And then for a period of time, gave them some antibiotics. And, for those who aren't necessarily in the microbiome world, you have an aspect of using a germ-free mouse, which is kind of like a mouse in a bubble who has no bacteria and so forth, or an antibiotic treated to eliminate the bacteria. Germ-free mice, as you could possibly imagine, are really expensive to house. The facilities have to be super special and built in a way. So antibiotics is usually a nice way to very inexpensively conduct experiments on a lack of a microbiome. So they gave these, female mice an antibiotic treatment, and kind of then looked at some of the outcomes related to hypertrophy and adaptation and so forth. And, noted that there was a disruption in the ability of the type 1 muscle fibers, which are the more slow twitch associated with aerobic capacity, to hypertrophy. And I think that was a really exciting finding to start, this platform of, us now getting some data out there on what we've been seeing in the skeletal muscle of mice that we've been working with. And, anecdotally, it's always interesting to, do you know a lot of people who like to work out on their antibiotics, or when they're being on, treated on antibiotics, and know that's confounded by maybe their illness. But, as we were talking, it would be interesting, maybe just give healthy individuals, humans, antibiotics for, a week or two, something that's pretty broad spectrum, that's going to knock a bunch of things out, and see if that kind of eliminates the training induced adaptations to exercise. And
yeah, and that'd be, I don't want to say an easy study to run, because no studies are easy when you involve human subjects and all that kind of stuff. But in the grand scheme of things, compared to what you could do, it's on the easier end of the spectrum, right? You could make it a randomized, blinded, placebo control. You could have, markers of aerobic performance or VO2 max, or things that are commonly available in the lab. IRB approval would probably be relatively easy, all things being considered. So it's definitely, I think, something that's quite doable without, $1 million equipment and everything else.
Right. No, definitely. And even just showing maybe that, VO2 max is reduced is a place to start, because,
right.
That's some of what we're seeing in our lab is things like work to exhaustion and running distance are significantly reduced, when we give the mice these antibiotics. And this seems to be, whether they are, male or female mice, it seems to be equivalent across the way. What's interesting is the lack of the microbiota kind of eliminates what many have shown is a sex difference, in particular of female mice tending to run more than male mice, which
interesting.
It's translatable to humans. But understanding those sex differences becomes a really interesting, phenomenon, what might regulate that. But that loss of microbiota eliminates that. All of a sudden, you don't see males or female mice being able to, have as long a running distance and or work to exhaustion. So
could some of that be related to the microbiome in female versus male mice just at baseline that's allowing the female mice to run longer?
Right. So we definitely have noticed, so all these things I'm talking to you guys about, I'm like throwing out there in papers in prep, right? So hopefully the next 4 papers during this get out before someone decides to scoop us. But, we definitely noticed there are baseline differences in the communities that are predominant in males versus females. And this translates, very, at least minimally, to the microbial derived metabolites, which a lot of times are measured as the short chain fatty acids. And those are very different between the male and female mice. So then becomes the, mechanistic studies, which we're proposing to really try and tease out, which aspects of these become important in the females versus the males, and how they might be linked to exercise capacity. So there definitely are baseline differences. Most, humans also, a lot of human studies report differences in microbiome between, sex. So, that's a fun question that we hope to answer over the next couple of years.
Very cool. And if we back up to the hypertrophy study that was done in mice with the type 1 fibers, it only affected type 1 fibers. And do we know the mechanism? Was like muscle protein synthesis changed, or any ideas as to what might be going on more further down the molecular chain, I guess?
I think that they probably looked at a couple of things. I have to go back and maybe email you and we can put it
that's fine,
an addendum. But I'm sure they looked at a couple of things. That they have a huge skeletal muscle, phys lab down there. So I know that they engaged in looking at immunohistochemistry and various aspects within the muscle. I don't want to misquote them. So
no worries.
So let me go ahead and I'll send you some of that data.
Perfect.
Published, so I can forward you that information. But it's really neat, and especially since they used female mice and showing this disruption to the type 1, muscle fibers, because we know females typically have a greater abundance of type 1 muscle fibers compared to males anyway, which sometimes is linked to, the aerobic capacity and the maybe drive for, some females to be in longer distances and as opposed to maybe males. So it's been an interesting exploration into sex differences with the grant that we just put out here right before Thanksgiving, looking at a lot of those areas.
Yeah, and I think in humans, like the only events that are coming to me that I guess for more strength and power or pure endurance, that females have actually won more considerably as more ultra marathon events, correct?
Well, yeah. So in addition to the type 1 fibers, they show a lot less fatigability compared to males. So it would make
Right.
they have this drive to kind of go longer and further. So,
And I've often wondered, how much of that do you think is females are just better at pain management? Because if you're doing like an ultra marathon event, which I don't do, I got to imagine at some level, it's a lot of it is just pain management. I mean, even if you're at the elite level, it's just a suffer fest.
yes, the longest thing I've ever done is a half Ironman, and I can
That's brutal.
sure, yeah, it took about 7 hours.
Oof.
Yeah, so and there were definitely times. I mean, it's Panama City. I did it while I was in doctoral school, and even in May, I mean, it is scorching. So the cramping and, trying to get off a bike after 56 miles and then run a half marathon. So I would definitely agree with the whole pain management aspect. You just kind of, almost got to get in. That's where sports psychology becomes really interesting. You just got to keep telling yourself, you just have to do it, get through it. You'll be, almost there, one more mile and then reevaluate. And then, okay, one more mile and let's see how you engaging a lot of those kind of mechanisms. So.
Very cool.
Yeah. So, but that interestingly, brings us to, some of the interesting aspects of looking at the way the microbiota might interact with the skeletal muscle. And so in addition to the changes in hypertrophy, there's some really interesting changes to, oxidative capacity of the mitochondria. So we're, really interested in taking a look at skeletal muscle and looking at things like, cytochrome 4 and, citrate synthase activity, all of those kind of key markers that are typically looked at. And, it seems that with the antibiotic training or the antibiotic therapy, it really does eliminate the training induced adaptation to those. So you see the typical response where it's, has a baseline level and then will significantly increase as a result of exercise, which is, the norm. But then you see, with just a week of this antibiotic therapy, that training effect is eliminated. And oftentimes it's even below what baseline would be.
Oh, wow. So it even goes negative.
So it even goes, to a much lower extent. And so, the next question, as you've been asking, is what's driving that?
Right.
The questions are, we're not sure yet. We're collaborating with people who look at this transcriptome and the genome, so to try and understand what that looks like in the skeletal muscle, pre-exercise training, post-exercise training, and then what's there and what's not, when the antibiotics are given. We're looking at the metabolome as well. In fact, my students just dropped those samples off, last Friday to start looking at some of the metabolome with the antibiotic treatment as opposed to, pre and post exercise. So I think those will start providing targets to where you can, start making valid hypotheses about what might be, interfering here or there. So I don't know. We'll see. It'll be really interesting.
Yeah. If you were to speculate, do you think this is transferable to humans, or do you think this is something we're seeing only in mice, right? Because the criticism of mice research or mouse research all the time is, oh, great, it's in a mouse, it's not a human, blah, blah, blah. But at the same point, you have to start somewhere. As you know, there's tons of things you can do on mice, very easy, that are almost hard or impossible to do on humans. So it's a valid question, but at the same point, there's pros and cons to both ends of the spectrum.
Right. So that's an outstanding point. I mean, we get asked that a lot, particularly with microbiome, research,
right,
simply because, humans have such varied diets compared to a mouse, where you're feeding either that control diet and they're happy to eat it every day, or a high fat diet, which they're happy to eat every day. And the reality is they're similar through certain levels of taxonomic resolution. But clearly, when you start getting into the much lower levels, which species are there, what strains are there, there's obviously some overlap, but that's where you're going to see some of the divergent things. So ensuring that there's some replication with humans would be nice. And we do know that there is some of that with some of the data that's come out, in particular with some of the Faecalibacterium prosnitzi and some of the butyrate producing bacteria that are seen in humans, as well as the animal studies. So that's a nice kind of like check mark that we're at least in the right realm of things. But yeah, so, designing those kind of studies, as you said, would be, quote unquote, as we say, easier. Again,
Right.
that they're not totally easy, but I think that they would be interesting. What might make it a little more complicated to answer those questions in terms of an IRB is the desire to get, say, a muscle biopsy, right? Because then you'd be able to take a look at the muscle biopsy and run some of those, what do the mitochondria look like? What do their enzymes look like? Do I think it would translate? I'd like to think that there's probably something there that, the microbiome just doesn't, control all of these things in animals and does nothing in humans. I mean, we're aware that, diet and, exercise do produce effects in humans, and the microbiome is responsive to both diet and exercise. So I don't see why, exploring what we're seeing in the mice in humans would be invalid. And I wouldn't be surprised if there was some overlap with that data.
Oh, very cool. I'm just going to turn my video off here a sec because my internet connection was kind of unstable there, but hopefully that'll help.
Okay. Well, what do you think? I'm curious about what you think. I think it would be, I think there's some things that are
similar. I think we're having a little internet connection here. Can you hear me now?
Yep.
Okay. Yeah, so hopefully someone, maybe your lab or other lab version of that, because it's something I think that athletes deal with not all the time, but a fair amount, right? It's not one of these far out things that just never happens in sport or to people exercising. So it's something that would be interesting just from a performance thing. And then obviously the whole yeah, so I was just saying that it's something that does happen to athletes. So it'd be interesting to see if one is a real thing in humans, and then two, obviously the mechanistic path of what may be the result of that, or the quote, the cause of it.
Right. And again, our lab gets interested in sex differences. So does it work the same?
Sure.
Right. And chances that is more reality, that the chances are that the difference between the sexes don't work the same way, that there's a different mechanism, mediating something. It might eventually converge on a similar, aspect, but it might not work through, similar pathways, which is what I would anticipate.
Yeah. Super cool.
Yeah.
So how long before we have a probiotic supplement that will target aerobic performance?
Right. So that's interesting, because there are some already out there. I think the last time we chatted, we might have actually looked. So I probably should take a look. But there was a Fit Biome probiotic that had been either released or in the works. It was in response to the paper that came out looking at the that showed this villanella, I think that's how you pronounce that, species that appeared to be linked to lactate metabolism. So lactate more on the consumption side rather than the production side. So this microbe might have been helping to, kind of process the lactate in the marathon. And I am pretty confident there was, like I said, the Fit Biome had developed something. I'm not sure if it's on the market yet.
Interesting.
Yeah, so I'd have to check. I know the one microbe that tends to be really influenced by exercise, and among other things like diet, Faecalibacterium prosnitzi is definitely already a probiotic out on the market. So anybody who hears that microbe and says, oh, I hear it's been associated with, exercise, could think to take something like that. But my guess is it's probably not. If that one isn't already on the market, there's others potentially in development.
So do you think that the current probiotics would be beneficial. I know we chatted about probiotics a little bit last time, and a follow-up part to that is probiotics in general. I believe after you stop taking them, you kind of then revert back to more baseline. You're not really, lack of a better word, permanently changing the landscape per se.
Right. So you definitely got that 100% correct. So the first, we can intertwine, both of those questions. So, the second part first, because that'll kind of lead into then, what about probiotics and so forth. So believe it or not, that the biota really, or the microbiome, I should say, is pretty fixed starting around the age 2 or 3. That's pretty kind of well established. So, things like route of birth, bottle fed versus breastfed, introduction to solid foods, early life exposure to antibiotics, and all of these things tend to shape that microbiota until, like I said, about 2 or 3 years old. And that's then kind of yours. And, what's interesting is it kind of takes a chronic application to change the microbiota, which is a lot like exercise, right? When you
Right.
exercise, when you stop exercising, you tend to start losing those effects, right? And so the microbiome works in a very similar way. You can take a probiotic and take it, but you kind of have to keep taking it every day. Otherwise, once you stop, it potentially, will revert itself back to what your kind of regular normal microbiota was, as established when you were younger. And so what's also really interesting about probiotics is that, the common ones are, the bifidobacterium and the lactobacillus. And we know that those are really important beneficial microbes, and they might regulate the populations of some of the other pathogenic ones. But with regards to exercise, I always like to show a slide during my talk when I talk about pre and probiotics, is that a lot of the microbes that seem to be benefited or altered as a result of exercise training, to your point, you don't necessarily see in what the typical over-the-counter probiotics are, right? So the development of an exercise-specific probiotic would be interesting to see how that is, but you might be giving someone lots of lactobacillus or bifidobacterium and ignoring the other, microbes and what we call genome interaction groups, and how these microbes kind of work together in communities to be symbiotic with the host. And you might be kind of pulling that in one direction if all of your feeding is a probiotic geared towards bifidobacterium and lactobacillus, if that makes sense.
Yeah, it's kind of like, what are the unintended consequences of it? It's like
Right.
supplement companies in general, consumers, everybody, we want the answer for the thing. So it's like, oh, this particular strain, well, let's take a whole bunch of that and then it'll help everything. But like you said, maybe that disrupts the whole ecosystem, and maybe you get a little bit of aerobic performance, but your gut health is a disaster now. Who knows?
Right. I mean, the idea is, what are there, trillions upon trillions upon trillions of microbes. And while granted, there are ones that, researchers believe are foundational and critical for the overall stability of the microbiota, but they still all have to interact together in that community to keep each other in balance. And, pulling those in any sort of direction, might not be the best idea. I mean, I think that there's a reason that the NIH is still calling for mechanistic studies of how probiotics work to, illuminate the fact that we really aren't sure how or why or if these are working. So I think that that's, a point to be, taken. We do know that, the ISSN released a position stand on probiotics, and, basically, most of the literature will suggest that it's more, not directly helpful, but maybe indirectly helpful on reducing sick days. But outside of that, the evidence isn't exactly overwhelming for showing that it definitely improves, aerobic capacity or anaerobic capacity. It's more of an indirect help, as in, hey, if you're sick less days, you can train more days, right? And that might be beneficial for performance because you're not taking days off.
Yeah. And obviously the context we're talking about here is, in my little air quotes, generally healthy people. Once you get into, pathologies and that whole area, that's a whole nother realm in and of itself too.
Right. And I mean, because diet is such a big modulator of the gut microbiota, I mean, your little air quotes kind of gets extended when you start talking about these athletes because they might tend to eat better, right? So there are several factors that might shape their microbiota that are, different from, the average individual, right?
Yeah. Very cool. Before we transition to some possible stuff on temperature, anything else in the area of gut health and probiotics and interesting stuff you wanted to share?
I don't know. I think that's about it. I think, a lot of the big things with the bugs isn't necessarily a probiotic, but a prebiotic. So
Hmm.
the bugs, the foods that they like, right? They like those complex carbohydrates, um, you know, to create those short chain fatty acids, which keep the gut healthy. So, as we always, teach our students in the nutrition classes, make sure that you have, enough total calories, and then you start getting into, that balance between the carbohydrates and the proteins, and then the fat and discretionary calories. And I think using that prescription, especially engaging in the fruits and the vegetables and those fibers that the microbes like to degrade, really kind of will help promote that healthy gut.
Awesome. And can you supplement like the short chain fatty acids themselves? And is that beneficial?
Right. So I think there have been we're starting to have come out with some more studies on that in humans. It would be great to think that you could do that. I think the other question is, do the short chain fatty acids work to augment that gut health, which then in turn, augments systemic health through, again, mechanisms that we're trying to figure out? Or is it the actual, serum or plasma concentrations of the short chain fatty acids that elicit those healthful responses? So I think that we have to kind of be sure, which aspect of the short chain fatty acids are actually creating those beneficial effects. Is it the ones in the gut that then, signal downstream to other things that then regulate systemic health? Or is it a systemic short chain fatty acid that actually pulls off the, health benefit?
Yeah. So kind of like, if you use a street analogy, like which way is the street going?
Right, true. And chances are, and sometimes I'm a big believer that it's probably bi-directional,
Yep.
but elucidating that is going to take some time to, get to those mechanisms. I mean, there's still just so many things out there that, hasn't just been looked at in terms of who is doing what, or who is where in response to what kind of exercise. I mean, largely the exercise that's been looked at has been a lot of, aerobic stuff. People are just starting now to publish other areas and resistance training and, swimming as opposed to running, or cycling as opposed to running. So I still think that there's some level of characterization that still has to occur within the exercise realm that's not as well defined as diet. So
Yeah. And that's for context for people listening. Most of that is derived from just the equipment and stuff that we had to measure things. Right. If you look at a lot of the old school labs, it was a treadmill, and even back to like when they had, Douglas bags where you're trying to, collect expired gas. So that was the only thing that was really investigated, because the tools of the time was kind of the only thing you could really look at. And so now, as technology is evolving, we've got other ways and other methods to look at things. We can look in different areas, but as you know, in academics, a lot of it is derived from certain labs have only historically looked at these things, and that's just what we do in this lab. Sometimes
right,
trying to change the
right,
culture of it is a whole nother issue on top of it.
right. And then designing a study to look at things. I mean, if you were,
Right.
you'd have to really sit down hard to look at how to best design, say, a resistance training study meant with a microbiome related outcome. right? And
Yes.
there's then all those variables. Okay, well, how many days a week, and how do we break it up? Do you just want to look at lower body exercises, upper body? Chances are you need some combination of the both, because a full body workout would be a little bit more equivalent to, say, an aerobic bout. And then do you compare them? And then, okay, then we have to, okay, are calories expended the same? Is total work done the same? And I think these are some experimental designs that, take a lot of time to implement.
Oh yeah.
Recruiting, as you say, the air quotes, like, yeah, those are the human studies that, take a lot of time, and getting those people into the lab and making sure that they're recording things. And of course, since the microbiome has such a, or is so influenced by the diet, either feeding them, which takes on a whole new level, right?
Yep.
Having them stick to a pretty regular diet throughout the time of the study, and really recording that is another thing. So when we start to add those layers of complexity, and I hope, people who are listening can be like, wow, okay, it's really not that just simple to take, somebody and figure it out, because you can certainly take, okay, these guys have been resistance training for 5 years versus aerobic training, and then, get some poop and run some analysis. But the idea is also to understand, though, how training influences the microbiota. So you'd want to not just engage in, okay, people who've been doing it and what are the differences, but what happens over time, right? Because those beneficial changes are what become important then for long-term health, right?
Yeah. And I always think a lot of the publication and studies that are more rewarded are the more complicated ones. And I think that's great. But when it's a new area, I actually even like early pilot data to see, does anything change, right? So we have healthy people. We did X program of lifting and we gave them this diet. Is anything different? And that's not a really as a sexy question as an intervention comparing the two things. But to me, that's almost more interesting, because you want to know, is this really a thing? And then once it's a thing, then we can look at, okay, well, how much of this is related to volume or upper body or lower body or all the things you said too. But the criticism of those studies, which rightfully so, is, well, it's a pilot data, so your stats may not be the best. And who knows if the thing you picked is the thing that actually moves the needle. You could have maybe picked something else, and then it does. So you can drive yourself crazy, especially early on, with all the what ifs, because you just don't have any data to base stuff on.
Right. But, to your point, though, science has to start somewhere, right? And
right.
If it generates a few of those what if kind of questions, then you at least know, or at least have a start to avenues that you can pursue. We always say sometimes the best science generates more questions than it answers. And I, have found that that's been largely true.
Yes.
Doing. And you just kind of say, okay, well, that's great that it generates these, which means we can say, then how do you get the best bang for your buck going up? Because science gets expensive quickly when you start kind of pursuing those exciting areas.
Yeah. And the way technology is going too, you may be able to get samples from some earlier studies where they did an intervention. So for me personally, I would love to see, and I know getting bloods and poo and all that stuff is a whole different approval process and everything. But even if you don't have the budget to do it, if you've got a really nice intervention trial set up, just get the samples and you can run them later if you have to, because I think we're missing, because the next question is going to be a mechanistic question, and you're probably going to need bloods and samples to get at that level. And who knows what technology we'll have to look at a blood sample in 10 years from now. So I think just collecting those would be well worth the time and effort, even if you don't have the funds to do much with them at that time too.
Right. No, I agree. And, barring a massive -80 collapsing on
right.
those samples really do stay pretty stable over time,
Yep.
and keeping them in there, frozen, especially if you, like you said, design the study well to collect the samples in the appropriate way. And at the moment where you think it's, the most beneficial, then I couldn't agree with you more that it's worth saving those. And down the line, when you eventually get the money, because you eventually will, it might not happen all at once, but you eventually kind of reach that point where, you start getting funded for your stuff and being recognized. And that's where you're going to be thankful you saved that stuff.
Yeah. Because especially when you look at some of the older studies that have been done, like it's almost impossible to think of all the questions that are going to come out of it, but we're getting to the point where we'll have things that we can then analyze to potentially answer them.
Right.
But if you don't have it, you can't look at it. So
right, exactly. And I mean, trust me when I say, especially for collecting, fecal samples, yeah, you have some of the fancy tools, but that little plastic cup with the scooper on the end of it that they give you doctor's office, or even when you go to the vet with your animal and you have to collect things. I mean, those things cost like $1, believe it, and so splurging on some of those just to then put them in a little cryo vial and get them in the freezer is worth your while.
Yeah. And transitioning a little bit, we got about 9 minutes or so here.
Sure.
I think you had some data about temperature differences, correct?
So we have some, we have a model of, it initially started as longevity and enhanced exercise tolerance that appears to work through brown adipose tissue. And so I think that we know brown adipose tissue is thermoregulatory through the uncoupling, mechanism. And so, we've been kind of tasked to take a look at if there's links between how the microbiota might be linked to the brown adipose tissue and its activity and metabolites that might be associated with that. So there is definitely evidence to suggest that the microbiota is, linked to thermogenic capacity. So lack of a microbiota and the ability to have cold tolerance, that kind of data is out there. So we're just, following up on some of that existing literature to find out in this animal model of enhanced brown adipose tissue of what's going on. Microbiota look like? What do those metabolites look like? What does that transcriptome look like? And how do you start linking those together to, yes, regulate temperature?
So is the proposed hypothesis right now that if you're doing, say, cold water immersion or cold exposure, that is then changing something in the gut microbiota that is providing positive adaptations via changes in brown adipose tissue?
So in some ways, yep, that's exactly what some of the hypotheses are. And for a change, Mike Nelson, we have animals and there's a human study going on.
Yay!
Actually, I have a meeting about that next week. So there's some human aspects of that going on right now, and investigating, what are those microbes? How are they changing? And then trying to start again, linking that to, are there metabolites in both animals and humans, both in gut and, systemically, or in animals, we can actually look at the metabolites in the brown adipose tissue that might be regulating that thermogenic potential.
Very cool. So do you think if you were to highly speculate that cold water immersion or exposure to different temperatures would be, if I use a general term, healthy, right? So if someone's looking to maximize health and longevity, do you think exposure to different temperatures would be something to consider doing?
If I had to be totally honest, I've never thought of it that way before. Because like cryotherapy are kind of out there for recovery, right?
Right.
Exercise and or, intense kind of things. That's a good point. I mean, the animal model, and this data is published, so I'm not saying anything. The animal model we use that has enhanced thermogenic is a healthful living model. So it does live longer than its wild type litter mates, and does have this enhanced brown adipose tissue that, as crazy as it sounds, when actually is transplanted to its wild type litter mate, the phenotype actually will translate.
Really? So basically in English, it works if you transplant
it. Works if you give, yes, in English, yeah, if you give that, special brown adipose tissue to its the kind of wild type, which is the normal mouse,
right?
Takes on the characteristics of the, of the quote unquote special mouse.
Huh.
Yeah.
And then if you take the wild type mouse and do cold water immersion exposure to it, can it expand the brown adipose tissue in and of itself to reach the levels of the other mouse?
So it does. It does have an enhanced cold tolerance test as seen in the enhanced mouse. Yep.
Oh, interesting. So the transplant in essence is working to provide the thermogenic benefit, which is resulting in enhanced cold water benefit.
Yeah, as well as an enhanced exercise capacity.
Huh.
Which is really, quite interesting. So, that's the other, aspect. And of course, we're messing around with the antibiotics and seeing what that does to the microbiome. And I have to keep you posted on that, because we're currently looking at that data right now. And
very cool.
I have to keep you posted as to what happens with that. But yeah, there is that ability. Aging in 2018, in Aging Cell, that paper on the RGS-14 came out. So that
okay.
is there. Yeah. For anyone who's interested. So yeah, it's interesting, model. And so the idea is that we're going to replicate some of these transplantation studies and see, because we've already, looked at what special microbes are in this, or in this special mouse. And then, so does it happen that when you transplant the brown adipose tissue, do these microbes kind of appear over time? Right. And then the flip side would be, fecal transplant. So is it the brown adipose tissue driven, or is it the microbiota driven? So we're going to try and look at both avenues.
Oh, that's awesome. And my brain also goes to, hey, can we take a probiotic supplement before we do our cold water immersion to see, greater upregulation in brown adipose tissue? And
right.
Who knows?
Right. Yeah, it would. I think in humans, like there's some people who have brown adipose tissue and it's overly active, and some people who really don't, or have very little and it's not very active. Right. So, there's all these things in place to ensure that you have, these brown adipose tissue and that it's responsive, and trying to get all of that sorted out makes always experimental design interesting, right?
Yeah, my hypothesis, and there's a little bit of data to support this in humans, is that brown adipose tissue is very, very plastic, meaning that if you're being exposed to cold water in a kind of eustress model where you're adding a little bit, time and time again, that it's going to expand just as a adaptation to that. And if you just grab people off the street who generally live in thermoneutral conditions, you're probably not going to find a lot of it. So
right. Yeah, no, that doesn't surprise me. The body is very interesting the way it works, right? When it has to adapt, it will. And that's what makes our area so exciting to study, right?
Yes. Yeah, definitely. Awesome. Well, thank you so much for all your time, and give a short plug for your program there, and if you're looking for any more graduate students, and how people can find you.
Yeah, sure. Thank you. I'm, as Mike said, I'm Sara Campbell. I'm at Rutgers University in the Exercise and Gastrointestinal Health Lab. We are the Red Dragons, so you can find us on Twitter. We're always looking for great people. So if you look up Sara Campbell Rutgers, you can find my email address, and don't ever hesitate to reach out, even if you have a random question. I love answering those just as much.
So you the Red Dragons now and not the Poo Crew, or are you kind of both?
Oh, we've always been both, but our true lab identity, really, the kids are the Red Dragons. And then, we're like, oh, they do the Poo Crew kind of stuff. It's kind of a, association.
Got it. Awesome. Well, thank you so much for all your time, and thank you for doing all of the work and all the research and managing all the studies and teaching on top of that, and taking time to talk to us about like new stuff that is just on its way to being published, and really appreciate it. It's awesome stuff, and I think we'll be learning a lot more in the future. So thank you for all the work.
Well, thank you for having me. It's always a pleasure chit-chatting with you. We always come up with some exciting things to talk about.
Yeah, and it's easy for me just to sit here and lob crazy ideas at you, and you guys are the ones doing all the work.
Right. Well, those kind of things are the way, future experiments get designed, right? And where those ideas come from.
Yeah. Cool. Well, thank you so much. I really appreciate it.
Anytime.
Thank you. Thank you so much for listening to the podcast. We really appreciate it. If you could help us out, assuming you enjoyed this episode with brand new research that's not even published yet from Dr. Sara Campbell here, by hitting the old subscribe button, and then you can leave us a review, whatever stars you feel are appropriate. Make sure to read all the comments, and if you enjoyed this one, share it with someone else, put it up online. Really appreciate it, getting a science-based approach for fitness to as many people as possible. And if you enjoy a science-based approach, check out the Flex Diet Cert. It opens again in January 2022. Best place to get on the wait list for it is flexdiet.com, FLEXDIET.com, and you'll be the first people to be notified once it is open again. Thank you so much for listening. Greatly appreciate it. Talk to you soon.